Hello, hello, guys. Howdy. Hope everybody is being safe. Today we're going to talk about EGR systems. I have to admit I've already tried making this video twice, and I keep forgetting to click the button that will let me download this video so that I can upload it on YouTube. And so I'm going to give it a third shot here. I've rechecked it twice, so we're good. So our subject of the day, and I'm outside. You can hear the wind chimes, wind's blowing. I'm surrounded by my flowers, my neighbors. You can see my big old snowball bush over there. I got some various plants out in the front yard. A few of them didn't make it through winter, but it's a beautiful day out here. I do have some birds that are really mad at me for being out here, but they have some nests right in on the porch here, but it's a beautiful day. So let's talk about EGR systems. I will admit I was one that I used to pass off a lot of the stuff that I saw. I thought they were joking when they talked about smog. I thought it was just, hey, Los Angeles is that dirty. New York is just that dirty that there's so much dirt and smut in that area that there was a brown haze that just surrounded the place. But what I ended up finding is I was on a trip to Orlando, had to go down to Orlando, and I was on my way back flying into Greensboro, and it was a fairly clear day. Wasn't a whole lot of clouds in the sky, and I could see this ugly little haze. It was like a brown haze over top of Greensboro. And finally, it hit me. This is what smog is. And it's not just bigger areas. Greensboro, Winston-Salem, we're not a hugely populated area. Not like New York City, not like Los Angeles, San Francisco, those areas, Chicago. And we have some smog that's over top of Forsyth County and Guilford County. That's why Guilford County was required to go to emissions inspections. Forsyth County was also required to go to emissions inspections for our cars. And that's one of the reasons, one of the many different reasons, was air quality. So one of the big contributors to that haze is oxides of nitrogen. Oxides of nitrogen are when the combustion process happens, the nitrogen is split out of the air. The oxygen is split out of the air. They're separate in the heat of the combustion. We're going to merge those two together. Oxygen is going to combine with nitrogen and form NO. Or two oxygen molecules will combine with one nitrogen molecule and form N2. Or we can get three oxygens and one nitrogen, and that is NO3. That's why we call it NOx, because it can be 0, 1, or 2. And either way, no matter which one it is, we don't want it. We got to cut down on it. Well, our converter does a good job of this. Does a good job, not a great job. It can handle what's being produced under normal driving, but under some conditions, we're going to get the engine hotter than normal. So, and this happens a lot more than what you would think. crews just driving down the road under a light load, especially on a hot day, the combustion chamber will tend to get really, really hot. So we need to do something to bring that temperature down, because if that temperature exceeds 2,500 degrees Fahrenheit, then we produce a lot of NOx. And it may be more than the converter can handle. So we've got to find a way to keep it down to what our converter can handle. So that brought about the EGR valve. This is a valve has a bad name, and deservedly so. It started out in the late 70s, in through the 80s. We had to use this valve to meet emissions, but we couldn't control the amount of EGR that we were getting. And if we were getting too much, we would get like a surging with the car. The car would feel like it had a little bit of a surge or a fish bite to it as this valve would open and close. And it did cause a slight decrease in gas mileage. So as time went on, the engineers just got better. Like with anything, they got better. They figured out what they were doing. They figured out the exact amounts that they needed for various engines. And life got better because we started letting the computer control it. Now the computer could take in various factors. What's the engine temperature? What's the ambient temperature? What kind of a load? Sorry, I got the hiccups. What kind of a load is the car under? How long has it been operating? What's the calculated exhaust temperature? And we could figure out what we needed to keep that temperature down and give it just what it needed, nothing more, nothing less. So today's EGR valves, I can tell you from trial and error, if you disconnect them, you won't be able to tell it driving it. It will make almost no difference at all in your gas mileage. You might get a quarter of a mile per gallon if you get that much. They just operate so well, there's very little effect on the vehicle. So here's how this thing works. We've got a valve down here at the bottom. This valve is just going to open a passageway between the intake manifold and the exhaust system of the car. It could be a tube that's screwed onto the bottom of this. It could be a bolted directly onto the intake manifold on a V-type engine and have a passageway underneath of the intake. There's a lot of different configurations, but all the valves work the same. So when that spring pushes this diaphragm, there's a diaphragm right here. When the spring pushes it down, it will close the valve off. No exhaust flows. If we apply a vacuum here to this port, then as we pull the air out of the upper chamber of the EGR valve, this is totally sealed off. When we pull the air out of it, it will compress this spring and open the valve up. The spring is responsible for closing it back down. It is also responsible for being calibrated to how much vacuum does it take to lift it up. So basically it's changing the amount of work we have to do just to unseat that valve. So you have to be careful of that. One of the first things I want to do if I have an EGR problem is do a visual inspection. Do I see any physical damage? Has somebody hit it with a hammer? Has it gotten bent? Is there any is there any damage to the post down here that stands on? This is like a shell. If it is, that will shrink this down, and that pushes up on the pinnacle, and it makes it so it takes more vacuum to operate. Open it up, it might not even open. Same thing, did the top get hit with something? So if I see any physical damage, replace the valve and then see if it works. If not, continue your diagnosis. But it will not work correctly, period, with any physical damage done to it. So with that said, let's go into how we're going to control that. You see how the valve operates, fairly simple. That's how the vacuum style works. This is a valve that is on a General Motors product. This looks like a Chevrolet 305 to me. Might not be, but that's what it looks like. I can't tell how many cylinders. I'm just guessing from the looks of the length of the valve cover. Our EGR valve is over here. This one is totally mechanical, no electronics in it. It is a straight EGR valve, though it may have what's called a negative pressure or positive pressure valve in it. I'll get to that in a minute. We have a vacuum line that runs to the EGR solenoid, or electronic vacuum regulator is what I think Ford calls it, is an electronic vacuum regulator. I call it an EGR solenoid. Then there is a vacuum line that runs over to the engine for our source of engine vacuum to operate it. So right at the back is a connector, hooks this solenoid up to the computer. Then our computer is going to calculate how long do we need to open this up, how much EGR do we need, and it's going to pulse width modulate the vacuum to the EGR valve to make it work. Now, I told you negative and positive. Negative pressure, positive pressure. Picture, if you will, a cutaway of one of the cylinders with a tube coming in from the intake and a tube going out from the exhaust. So when our piston finishes the compression stroke, it's at the bottom of the cylinder and it starts back up. We open the exhaust valve up. The piston's moving really, really fast, and it's going to start to compress all of those gases that are above it and push them out through the exhaust valve. When it does that, it does create a pressure because it's moving so fast. It creates a pressure and it dumps it into the exhaust system. And if you had a pressure gauge on the exhaust system, you would see a pressure increase in the exhaust. Now the exhaust valve closes. That air that was pushed into the exhaust is trying to flow down through the exhaust. It doesn't stop just because the exhaust valve closed off and wait for the next push. It continues going and it forms a vacuum behind it. So now, instead of a slight pressure, we have a slight vacuum. So if you can kind of keep that in mind, there's a valve on this type of system, these valves, in the middle of this pinnacle right here. A lot of times there is a small hole drilled with a bleed at the very top right here that I just circled in red. Look for that in red right here. That bleed will not allow vacuum to build up inside of this chamber unless we get the right pressure in the exhaust. So if it is a positive EGR valve, then when we have a pressure pulse in the exhaust, we close off that bleed, vacuum up, and it opens the EGR valve. As soon as that pressure pulse disappears, the bleed opens up and it bleeds vacuum off from the valve, and the cycle repeats with the next exhaust cycle that comes through. With these type of EGR valves, you put your finger underneath of them while they're working, and if you reached up through here and put your finger on the edge of that diaphragm, you would actually feel it fluttering. It wouldn't sit solid. It would kind of be bouncing up and down. If it's a negative, just the opposite happens. As long as there's pressure, we're bleeding off the vacuum. We're not letting it build up vacuum. As soon as there is a negative pressure in the exhaust, it closes that valve off, and now we build up vacuum in the top part of it, and the same thing happens. The only difference is whether it takes negative pressure to allow it to work or takes positive pressure to allow it to work. Now, this is one of the things you want to watch for. If you have a transducer of any type, whether it's internal or external to the valve, in a video that I'm going to post for you to watch, you'll see on my minivan, I'm showing you an external pressure transducer. If you have one of those and something has changed with the exhaust, maybe somebody put a high flow exhaust system on, it could keep this EGR from working. It could change the pressure enough in the exhaust that the EGR doesn't work anymore. If you have a positive type system, if you have a slight restriction in the exhaust, maybe the catalytic converter is a little bit dirty, it could cause excessive exhaust flow because it would never go from positive pressure to negative pressure. It would always stay positive pressure. So that was the big downfall of the early systems, is a lot of the cars that were getting EGR valves and the people tried bypassing them actually had slightly restricted converters. The converter was actually going bad, and they never found it. People would just blame it on the EGR valve, and they would block it off, which is illegal. Warning disclaimer, it is illegal to bypass an EGR valve. You can go to jail for that. So don't do it. Find out what your problem is. The older cars, yeah, you're going to feel them. The newer cars, you should not notice a drivability difference with the EGR or without it. We're controlling them really, really, really good. So that goes through negative pressure, positive pressure type EGR valves. Ford was one of the first manufacturers to do this. Most manufacturers have had a version of this. Toyota has a version of this. I'll show you a valve in another video that I have here that I'm going to show you. The one that I'm showing you all for the car, not the one on my van, but the one that I'm showing you while I'm sitting on some cross ties that I have over there. It has a sensor on top of it, and Ford came out with this, and they decided, hey, if I use this sensor right here, and we can tell, did this EGR valve open up? Did it stay open and it wasn't supposed to be open? Or is it opening up too much or not enough? So they started monitoring that, and other manufacturers kind of followed suit later on. Chrysler has used it, GM has used it, Toyota's used it. Lots of manufacturers have used this. Ford called it an EVP, exhaust valve position sensor, and all it is a potentiometer. It's 3 wires, 5-volt power, has a ground, and then it has a sweeper arm, just like a regular throttle position sensor, if you want to think of it that way. It's the same thing, only difference is instead of measuring the throttle movement, it's measuring the movement of the exhaust valve itself. How far did it open? Is it open? Did it close? If the sensor itself fails, then it will set a code. Generally, everything else is going to be a 2-trip failure. So if the valve doesn't close off because it has carbon up in it, then we will set a code for it, and check engine light will come on. That will match up. The customer's probably going to be complaining that the car runs rough at idle or that it stalls at idle, and that should lead you right to where your problem is. It's probably not the sensor. I've only seen a few sensors actually go bad in my career. Most of the time, it's the valve itself. The next version that we went to is we said, hey, what if we got rid of having to worry about vacuum? Because even with the other style that Ford used, this one was still vacuum operated, not that one. This one still has a vacuum line going to it, still has a vacuum diaphragm. We're still relying on engine vacuum, so we could have a vacuum line that goes bad. We still have to have a transducer in there, or not a transducer, but a solenoid to turn the vacuum on and off to it, so it operates when we want it to. General Motors came out and they said, hey, why don't we use a linear style? And this was actually their second choice. I'll tell you about the first choice that worked better than the vacuum operated one, but not as good as this one. Chrysler's used this type of valve. GM's used it. I don't know who all else has used it. Generally what I find out is almost anything out there, at least a third of the manufacturers have used it at some point or another, and tried one thing or another until they found what they thought worked best for their vehicles. So this one is a linear style. Instead of having the 3 wires going to it like the Ford style did with the sensor on top of it, we're going to put the sensor inside of it, and it's going to have 3 wires going to the sensor, but then we're also going to put a linear solenoid inside of it. This is basically the schematic for it. So what we mean by a linear solenoid is we're going to pulse width modulate the solenoid. But what it's going to do is it's going to work a little bit different than just a regular solenoid. We're going to turn it on and off so fast. What we're actually going to change is if we only turn it on for a short period of time, then we build up a small magnet. There's only a little bit of current flow. And in some years, they actually changed it around to it was not pulse width modulated. The PCM was actually controlling the amount of current flow through it, and you could actually watch that on the scan tool. It would give you a amperage flow, how much current is flowing through the solenoid down here. So we're going to apply battery power to the solenoid. The PCM is going to apply our ground, and it controls it. This way we could control the opening against spring pressure. We could open it up until we got the desired amount of flow, and then we could hold it there. So this one worked pretty good. Two of the wires over here that go to this is power, battery power, 12 volts, and a ground going to the PCM. That controlled the solenoid. The other three are this sensor, plain old potentiometer type sensor, 5-volt signal, a ground, and a wiper arm that moves with the pintle as it opens and closes, so we get a output of how far did it open or close. This way we can monitor it very closely, and we could control EGR very, very well, so you didn't even know that it came on. You didn't feel any surging. You didn't feel any changes in it. We open it up real slow, we close it off real slow. So you didn't notice it turning on and turning off. And it basically makes this system to where it doesn't work right without it. You don't even know it's there. You won't notice it if you get rid of it, because we're controlling it so well. We only give it what it needs when it needs it. Really great system. Several manufacturers have used it. While I'm on this style, General Motors used a 3 solenoid EGR valve. If you've ever worked on any GM cars, let me see if I can find a picture. If I can, I'll just share my screen with you and let you see it. It had 3 solenoids in it, and what sorry, I paused for a second because I'm trying to find the picture of the one that I want. It had 3 different solenoids in it, had 3 different valves in it, and they used it for several years. And I found one. I'll share my screen with you, so you can see what it looks like. Let me go over here, go click, go back down here to click. I want to go back here. I want to go back here to share screen, so this way you can see what this looks like. It has 3 different valves. I think I got to tell it to stop sharing. Why is it not letting me share my screen? Give me just a second if this does not work. Oh, I know what it is. It has to do with the way I went into this, so I can't share that with you, but if you go into it, if you go in and look it up, you'll see one. It looks like a valve with 3 solenoids at the bottom of it. And works fairly simple. Now, let me get back down to the picture we were looking at. Has 3 different solenoids. Each solenoid is controlling a separate EGR valve. So one of them has a very, very small orifice in it. One of them has a large orifice in it. One of them has a medium-sized orifice in it. So now we have 3 different doors, so to speak, and by turning on and off the solenoids, they have a fairly decent combination, basically about 6 to 7 different combinations of that they can come up with for varying amounts of EGR, but they're doing it through 3 different solenoids, not just one. But like with anything, the more parts, more expensive, the more there is to fail. So this type seemed to be a little bit better. So GM used this style, so did a lot of other manufacturers, and the other one kind of fell to the wayside. It was used back in the early 90s. Most of the GM cars, I think by the late 90s, they had gone to the linear style. Ford used something that was called a delta pressure feedback EGR. A lot of words in there. DPFE, delta pressure feedback EGR. The big problem with this was it was a great idea, but if we had a problem with the engine running rich, it could be the downfall of this system. So what's going to happen here is the main player in here is a little orifice that's down here. We've got a tube that runs from the exhaust pipe to the EGR valve, and it has an orifice in it. So think of this: if your garden hose gets pinched off, it gets a kink in the center of it. You open up the valve on the end of the garden hose, and you've just got a trickle coming out of the hose because the pressure after that kink dropped. The pressure before that kink is still there. So they use that principle, and we're going to use something over here called a DPFE sensor. It's basically 2 pressure sensors. We hook one of them into the exhaust. We hook side of that orifice, and we hook one to the EGR side of that orifice. We call it the intake side and the exhaust side. So we're going to read the pressures. So now think of that garden hose. The hose has a kink in it, and I close off the valve. I've closed off the valve on the end of the hose. Pressure will build up after that restriction up to that valve so that we have the same pressure in the hose from one end to the other. Nothing is flowing through that hose, and we have equal pressure. Now, if I open the valve up, pressure after that restriction is going to drop. So that's the idea of this orifice, is when we open the exhaust valve up, if the pressure drops after the orifice, then exhaust has to be flowing. And that's going to tell us exhaust is flowing, and by the difference in the pressure, we can tell how much. So now our PCM is going to be able to take that feedback that it gets and decide, did we open it up too far? If we did, then we change the duty cycle on the solenoid. If we didn't open it up far enough, if we need more EGR, then we increase the duty cycle on the solenoid. Fairly simple system, not a whole lot to it, but we added more parts. They added more parts to it. All of the cars had the EGR valve. All of them had the EGR valve. Most of them, unless it's the linear style or the GM3 solenoid style, have a electronic vacuum regulator, and all of them had a PCM. But in order to make this work, we had to add in this extra tubing, and we had to put an orifice in here. Generally, the biggest problems that you have with this system is the orifice clogging or the pressure sensor failing. It was generally one of the two of them. They didn't have a whole lot of VGR problems. Either the tube clogged up or the failed. Now we have to test this thing. EPA said this is an emission control device and we want to be able to test it. So we have to run a monitor. This is one of the ways that the monitor runs. It's not true for all vehicles. So some vehicles, instead of looking at engine RPM and map sensor, they may look at the fuel trim. Did the fuel trim change? If it did, it must be working. So what's going to happen is we're going to be out driving our car. So we're driving our car, and we're in this area. We're cruising down the road at a steady throttle, just cruising along at a steady speed, usually somewhere around 40 to 80 miles an hour. Steady load, nothing's changing. Engine vacuum is remaining constant. RPMs are fairly constant. The PCM will have the EGR closed at that point. When it gets ready to run this test, it'll let those stabilize. Then we're going to turn the EGR on. And what we're looking for is when we turn that on, did the pressure in the intake manifold go up? So pressure is going to go up, which means vacuum goes down. That happens because the EGR is basically a calibrated vacuum leak. We created a leak in the system to allow EGR to operate. Engine RPMs should actually drop slightly. If they drop, hey, this EGR is working. Intake manifold pressure went up. Engine RPMs came down. So EGR started to flow. So we turn off the EGR valve and we look for the vacuum to stabilize again, pressure to come back down, and we look for the engine RPMs to stabilize again. That tells us it closed off. If that happens, we pass the monitor. Now, on some vehicles, they will look at fuel trim to see if that EGR valve actually operated. So if the EGR opens up, we're going to allow less fresh air in. So it should change the fuel trim of the vehicle because we have less oxygen to burn, less going on. This is a two-trip failure. If it doesn't pass it the first time it runs it, we'll get a pending code. If it passes it the next time, the pending code goes away and life's good. Nothing happens. If it fails it twice, then we end up with a hard code and we turn on the check engine light to notify the customer that something went wrong. Now, one of the problems that over the years has been a problem is on some vehicles, we have passageways in the intake manifold for exhaust to flow through. We've done that on the V8s. Some manufacturers have done it on the 4-cylinders. And this is a picture of a Honda intake manifold that the passageways, you can see right up here, they took the plugs out of the passageways so they could get in there to clean the carbon out of them. That way they could clean it out. They didn't have to replace the intake manifold in order to do it. Then when you're done, pretty much what you're going to end up having to do is you take a tap and you tap some threads in here and then screw a pipe plug in it to close it back off. But it keeps you from having to replace the EGR. You can see in this passageway where the EGR valve was mounted right here. They've taped it off so they don't get any shavings in there. They don't want any shavings going in on the exhaust side or on the intake side of it, so they taped that up. After they took the EGR valve off, taped up the passageways. This is all in the exhaust stream. Usually what I would do if I clean these passageways out, if I had them open, usually after I got done, before I plugged them off, I would generally try to blow out any shavings out of that exhaust passageway. Try to keep it from getting into the EGR valve and sticking it open. It's usually not hard to do. The one thing this guy is doing here where he's tapping new threads in there that I did a little bit different, I always put grease on my tap. If I was tapping into something like this, I would coat the tap with grease, cut a couple threads, take it out, clean it off, put new grease on it, cut a couple threads. That way the shavings, most of them would stick to the grease that's on the tap, and I wouldn't have any shavings fall down in it. That's our EGR system, and fairly simple, not a lot going on with it. Sensor problems, solenoid problems, one-trip failures, just basic diagnosis. I'm diagnosing this rheostat circuit, 3-wire potentiometer, or I'm diagnosing a solenoid that's operating it. And if all that works correctly and the EGR valve is good, but it's failing the monitor, you probably have a clogged passageway. You just have to trace it out. Not a real hard system to diagnose. We don't have near the problems with them that we used to, because everything's cleaned up fairly well. So I'm going to end this video so I can get it transferred over to get the closed captioning added to it. And I will also post a short video that I did out here with my 98 Dodge minivan and show you a system that has a transducer to it. So you guys know how to get hold of me. Send me an email if you need me. Send me a text message to my cell phone. I'm always happy to hear from you. I hope everybody's doing well, and I will talk to you later, probably on Thursday. Look for a unit test, I think, coming. I'm not sure. I have to go back and look at our plan to see what we're going over. And I'll let you know what's coming up for Thursday a little bit later on. So everybody take care. Send me any questions. Let me know what you need, and I will be glad to do anything I can to help you out. So until next time, be safe, have fun, good day. Land us out.